Second day of 1-4 deals with Pythagorean theorem and distance formula. From a certain point of view, they are the same. They just look a little different. Hopefully by the time we're done today, you will understand what I mean by them pretty much being the same thing. As most of you probably already know, the Pythagorean theorem is basically an equation used to solve for the sides of a right triangle. You need to know 2 of the 3 sides, and you can go and find the third one. Later on this year, we'll start doing different things where you can solve for even more than that. As you see right here, it's a squared plus b squared equals c squared, meaning you have to take a and square it, whatever that is, b and square it, then add them together. Don't add them together and then square. All right. Here, this particular side is going to be the longest, and we know that because we know this is a right triangle. And how do we know it's a right triangle? Because it says so up there that it's the sides of a right triangle. When you look at it, how can you tell for sure? Yeah, a little box down there basically means right angle, and it measures how many degrees then? 90, very good. And we know that across from 90 degrees will be the biggest side, if it is a right triangle, and this one is. And that particular side has a name. Just shout it out. Hypotenuse. Okay, so I'm sure you've heard that before. Now, believe it or not, these other 2 sides, they also have a name, but they kind of share a name. Legs. Okay? And so if I use those words, hopefully you can understand what I'm talking about. The legs are kind of A and B, and hypotenuse is usually the C is how people state it that way. And that's why in the formula, C is all by itself on the right side over there being squared. And the A and B go together. Okay? Any questions on that? Again, I'm sure you've seen it before. So if we were to do this one, we were going to find the missing length. The very first thing I do when you are doing that is to find out which side don't we know. And this is the one we don't know, which happens to be across from the right angle, so we don't know the hypotenuse. So that's C, maybe this one's A, and maybe that one's B. I'm going to do something that maybe you haven't seen before, but again, it's in hopes that you get a little bit better at labeling and understanding, how they end up the way they do. So it's A squared plus B squared equals C squared. That's what it said on the previous slide. And so A, according to the way I've labeled, is 8 inches. Is it okay if I would have labeled 6 inches as A? Is that all right? Yeah, they're legs. It really doesn't matter at that point. And so A, according to me, is 8 inches, which I am going to square. What's different here is you notice how I put inches in there. Okay? And there's a reason for that. So 6 inches, which I then have to square, and apparently that's going to equal C squared. Okay? Again, that's kind of in our problem. If you want to write X there where C is, that's fine. It's completely up to you. So if I take 8 inches and square, well, the 8 squared, that's probably not that hard, right? 8 squared is 64. But what happens if I take inches and square it? Well, you get inches squared. Well, that's kind of weird, isn't that? As you say, that's because it's area, right? Well, wait a minute. This problem's not dealing with area. It's dealing with the length of a side. Why is it squared? That might be a slight problem. We'll have to see what happens. Okay. Plus, well, 6 squared is pretty easy, right? 36. That is inches squared as well, because the inches right there got squared. Well, now I'm getting a little bit more concerned. We've got inches squared everywhere, but this isn't supposed to be area, so that might be a problem. Can we add these 2 numbers together? Is that all right? Sure. Yeah, that's pretty easy, right? 100. And then is it inches to the 4th then? How's that work? It's still inches squared, right? But that equals C squared. Agreed? Well, in this problem, I don't want to know what C squared is. I want to know what just C is. Again, for us, C is like the X up there. That's how we labeled it, right? How do you get rid of a square? What's the reverse or the inverse of squaring something? What is that? Square root. Very good. Okay. Now, it's a square root like this. Any of you that had Algebra 2 with me, which is none of you, would have known that we kind of call that housify, because it kind of looks like a house when you're done. Okay, because they cancel, leaving you at C. All right. And then here's how I technically look at it. Now, you don't have to, but I'm going to show you how this works. Do you agree I could rewrite 100 as 10 squared? And this is already inches squared. Do you see how it housifies there and also housifies there? Again, that's the term that we use, housify, when I'm there. So C equals, did we take care of that square that was an issue for a couple seconds there? It was an area for a while, but when you take the square root, it just becomes 10 inches. Because if you take the square root of something squared, they cancel. Okay? Does 10 inches make sense based on what we saw earlier? Does that end up being the longest side? It does. Had we gotten an answer of 7, you should have been concerned. Okay? Because if that's 6 over there, that leg, and this leg's 8, that better not be 10 up there. So that most definitely works. Okay? Do you have any questions on what you saw there? I know it's probably a little bit different. You're not used to seeing the labels in there, probably. Okay? All right, if there's no questions, try number, was it 2 or is it letter B? What do we have it as? Number 2? Okay, go ahead, try that one right now on your own. Let's see how you did. As I went around, I saw a few of you making a slight error in judgment. Many of you just set it up the same way we did the last one. You did 5 squared plus 13 squared equals y squared. That will not work. Because what's the very first thing I did on this last problem? I said figure out which one you're missing. All right? So on this one here, well, which one am I missing? Am I missing the same thing I was missing before? No, I'm missing this one right here. So we could maybe call this A. Well, that has to be C because that's the hypotenuse, right? So this could be called perhaps B. If you like to go back to the A, B, and C, some of you do. Some of you don't. It's up to you. So here we've got 5 meters, which we have to square, plus, they'll call it, you want me to call it Y? I guess we'll call it Y this time, which we have to square, equals 13 meters, which we have to square. So this is 25 meters squared plus Y squared equals, anybody? 160, right? Nope. Meters squared, right? Okay. Now we have to subtract this over there because we want to get the variable by itself. And remember, like I told you, look at algebra as almost the reverse of PEMDAS. You're going to do any adding and subtracting you can first. It's the opposite. Yeah, so subtract. Those are gone. Now, does that end up being a fairly nice number? Well, there's what, a 4? You don't even have to borrow. Look. You don't even have to borrow yet. I saw a lot of you using a calculator. A little scary. Now, to get rid of the square, you got to take the square root. So this is y, because again, there it goes, cancels off like that. Really, you could write this as 12 squared and meters squared. So once again, falsify, and y is 12 meters. Any general questions on that? Well, I'll show you a few things here. This particular one then is 12 meters. Again, does that make sense? And fitting with the triangle, it does. This is one of these. This one right here is one of the very popular Pythagorean triples, is what they're called. If you see 5 and 12 on the legs of a right triangle, you can, without doing any calculations, put a 13 on the hypotenuse. But if they go like this, put a 5 here and a 13 here, that one's not going to be 12. Right? You see how they have to be in the right location? Okay. Another one that comes from this one is 10, 24, 26. They all get doubled. Okay. Those two are very popular. So wait a minute. So those two are pretty popular. Not bad to know if you can memorize them. What about this one? Is that also Pythagorean triple then? Yeah, it's 6, 8, 10. And normally when you say a if I could say it, Pythagorean triple, you go the 2 legs and then the hypotenuse. This actually comes from the most common of them all. 3, 4, 5. That's the most common of them all. You'll see it a lot. 3, 4, 5, and 5, 12, 13. The 2 that we just did here, all the time you will see those. 6, 8, 10. Yeah, you see that one quite a bit. 10, 24, 26, yes. And then there are other ones as well. Okay. So perhaps you'll learn them as you go. This next one right here is, I guess you could call it a Pythagorean triple, but it's not one you're going to want to memorize. Well, is it a right triangle? Yes, it is. But these 2 sides, the 2 legs are equal. So we could call it a right triangle, but we could also call it what type of triangle? Yes. Close. Isosceles. Okay? Can't quite go equilateral because remember, this one does have to be the biggest. Right? Well, we got 1 and 1. Well, let's see what happens. So we'll kind of call this A. We'll call that B. So there's our C. So we've got 1 centimeter, which we have to square, plus 1 centimeter, which we have to square, equals, we'll call it Z. Whenever I make a Z, I'll do that so you know it's not a 2. All right? Same thing with my S's, so it doesn't look like a 5. All right? So 1 centimeter squared. Well, what is 1 squared? I get some various answers to that. Don't be afraid just because I get different answers. It is 1, thank you. What's the most common wrong answer? 2, yeah, exactly. But it is just 1, right? So 1 centimeter squared plus 1 centimeter squared equals Z squared. 2, now that's when 2 should happen, right? 2 centimeters squared equals Z squared. square root z. Can I do with the 2 like I was doing with the last two, like 144 I made 12 squared, 100 I made 10 squared? Is there a really nice number you can do that with for this one? Not really. So basically you can just take the square root of that side. This still houseifies, but the square root stays. Square root of 2, you type that into your calculator, it'll tell you what, 1.414, and it'll just keep going on forever and ever. So that's when you have to read the directions. If the directions say to give an exact answer, that's what you should give, square root of 2 centimeters. If it says to round to say the nearest tenth, you would say 1.4. It all depends on what the directions say. So technically, you could consider this a triple if you want, because it does work. But I don't think you see that one quite as much as you see 3, 4, 5, or 5, 12, 13, or any of those. Okay? But technically, it is still a triple. Okay? Triple because there's 3 of them. Okay, any questions on Pythagorean theorem, or do you think you've got that down fairly well? Think you're doing all right? Now, I told you distance formula was actually Pythagorean theorem. You may not believe me now, but I will convince you by the end of our notes here today. Basically, it is just an equation that calculates the distance between 2 points. On Friday, we did, if it was, say, on a number line, right? If you had a bunch like this, and you had to say get from there to there, right? That's what we did on Friday, right? With the absolute value, you subtract and all that. Well, now what we're really talking about is what if we're sitting here on a coordinate plane, one's up there, maybe one's down over here. How far is it from there to there? Okay, a little bit more complicated, but really not that bad. This stuff down here is called subscript. It really doesn't put any bearing on the calculation. It just tells you basically which value to put in there. What I mean by that is if I look down here, do you agree that I have 2 points? Maybe they could kind of be the 2 points. Obviously, they're not these 2 particular points, but they could be, right? So I want to find the distance between those 2 points. And all I'm going to say is 2, 3 is the first one. So x1, y1. And this is the second one. So x2, y2. Okay, it's the first x, first y, second x, second y. And then all that subscript allows you to do is know which value to put where. So d stands for distance. I hope you figured that out. And then this big square root. So let's just go ahead and do this one. I will come back and do this another way, but I'm going to save that for more towards the end. So it says first to put in x sub 2. According to the way I labeled it, it's a 6, right? Minus x sub 1, and according to the way I labeled it, it's 2. And then once I figure out what that is, I do have to square it. Plus. Then it says take y sub 2. Well, that's a 3. It's right there. Minus y sub 1. Oh, there it is. 3. And I have to square that as well. Any questions how I substituted the 2 points into the formula? Any questions on that? Would it have been okay had I made this one right here x2, y2, and then this one x1, y1? Would it still work out? And yes, it would. It would work out just fine because of the squaring. Okay, it wouldn't be a problem. Okay, that's the beauty of it. You just label one x1, y1, one x2, y2, and you go. So here we go. We've got this huge grouping symbol of the square root. And inside that square root, I've got another couple grouping symbols of parentheses. And so basically I have to do 6 minus 2 first, which is 4. And then I square it. Over here, this is pretty nice. I don't know why I put parentheses, but 3 minus 3 is 0. So we'll work up here. Well, 4 squared is, well, 16 plus nothing is 16. And the square root of 16 is 4. Is there any label on that? Do I know? You know, it could be miles, it could be millimeters for all I know. I don't know. And so you don't label it. It's 4. We will revisit this problem in just a little while. Any questions on that? Well, let's try the same process on this one then. I'll label them for you. Well, this is the first one, so we'll go x1, whoa, y1, and x2, y2. Why don't you at least get it substituted into that formula and started, and then we'll see how you did. All right. Well, if we follow the formula, big square root. So x2, that's negative 6, minus, again, the minus is built into the formula, and then 9. But then I got to square them. And then here we've got y2, which is 12, minus is built in, but the other one is a -5, so you got to be careful there. If you get going too fast, it's very simple to make a mistake here. So grouping symbols all over the place. So basically we got to take what? -15 and square it, and over here it's add the opposite, right? Subtracting a negative, add the opposite. So 17 squared. Some people do not have 17 there, and then it causes some issues. Okay, so make sure that you fix that, because again, it is 12 minus a -5. All right, when I take -15 and square it, that's where some of your calculators will defy you. They will only do what you tell it to do. For example, on most of the calculators, if you type that in, it'll give you -225. Because it does order of operations, which is do the exponents first. Takes the 15, it squares it. It sees this as like a -1 times that. And then it multiplies by the negative. Okay? If you want it to actually square out that -15 squared, you better put it in parentheses. Then it will do the whole thing and will give you a positive 225. Again, they will only do what you tell it to do. Plus, does anybody know 17 squared? What is that? 280. I'm sorry. 514. Well, that is not a perfect square, is it? 514. So that's again where you have to look at the directions. Well, are they asking me to give an exact answer? And if they are, there it is, square root of 514. If they're not, you can use this little symbol, which is an approximately equal to. It's an equal to, or an equal sign that's not 100% sure. And let's say we wanted you to round to the hundredths. What would you get on your calculator? What does your calculator tell you if you round to the hundredths? Anybody, just shout it up. 22.67 is correct. That's what it would round to the hundredths, because remember it goes tenths, then hundredths. Okay, once again, I don't know the units. Now you might think the notes were done, but I told you earlier I was going to convince you that the distance formula is simply Pythagorean theorem in disguise. I've yet to do that, I'm assuming. Agreed, that's approximately where the 2 points are, correct? Your job is to try and figure out how far is it from there to there. Well, I'm guessing that if you tried to get there, let's say these are city streets, all these grid lines, and you tried to get there in an actual way, about how far do you think that is? $17. We haven't seen that number anywhere. And what if you try to get from here to over there? How far do you suppose that is? And I went left, correct? And when we did Pythagorean theorem, what was always the last step to take the square root, correct? That's where there's that huge square root over all of that. And they are both getting squared and then added together. Do you agree if you were to solve for this, you would basically take a squared plus b squared and then take the square root? And then some people say, well, what if I went the other way? Like, that's okay. What if you went this way? Make sure you hit the right spot, though. Isn't that still? I just got lucky. I thought I was off by one. It's still a right triangle. Do you see it? Pythagorean theorem in disguise is all it is. From here on out, some students actually just get themselves a mental picture of where the points are, and then they do it that way. They just do Pythagorean theorem. Okay? It works. Now let me show you what some of you, well, maybe unwillingly did on the last problem. You found the distance from there to there. Do you agree it's 4? Now that you look back, perhaps you realize how silly it was to use the distance formula on that particular problem. Hopefully you can get smarter as you evolve through this process. Okay? It works the same if you have to go straight up and down. All right, those are pretty straightforward. Okay? I wouldn't necessarily waste my time using distance formula on those. Be smart about it. But it helps to know actually what distance formula is. And it's Pythagorean theorem. So then you might wonder, well, where did the 0 come from on this blue line? Well, did I go up or down at all? No. So the up or down is 0. Right or left, 4. Still Pythagorean theorem, even though you can't see the triangle. Okay? Any questions?